This video is about how to do your best on questions about efficiency. Now, efficiency is quite a common word used to mean sort of you're not wasting time. If I'm working efficiently, that means I'm getting on really well. I'm not wasting time, I'm just getting on with my job. But in physics, it's all about energy. Now, the first picture shows you exactly what I'm talking about. Now, we know that energy must be conserved. So if I put 100 joules of energy into a light bulb, 100 must come out, but not all of it comes out as what I want. This light bulb, an old style light bulb, actually wastes most of its energy. It wastes 85 as heat when, well, it's a light bulb. I want light. But remember, the reason this is important is I pay for the energy I put in. I'm paying for 100 joules of energy and only getting 15 out of what I want. If I could get rid of this wasted energy, I'd only have to put 15 in. It would be a lot cheaper for me and better for the environment. Now, there's two equations to work out efficiency. They both essentially mean the same thing. Oh. They both essentially mean the same thing. It's the useful you get out divided by the total you put in, whether that's in terms of energy or power. Because these equations are energy divided by energy or power divided by power, you'd be using the same letter twice, so they're normally just written in full. But let's have a look at some exam questions. So we'll start off with one from a foundation paper. So the image shows a man using a leaf blower to move some leaves. The leaf blower is powered by an electric motor connected to a battery. The total power input to the leaf blower is 750. The useful power output of the leaf blower is 360. Calculate the efficiency. So if I was doing this in an exam, I'd write probably a brief version of my equation. Efficiency equals useful out divided by input. Now I put in the numbers in the right place. So useful power out is 360. Total input is 750. So I need my calculator to divide. Remember, you don't have to do any of these in your head. You can always take a calculator into an exam. My calculator says that is 0.48. So that is my answer. Now, some people like to put their efficiencies as a percentage. There is no need to do that. That will get me the full 2 marks. 1 mark for my working out, 1 mark for the answer. Whoops. 1 mark for the answer. But if you desperately wanted to put it in to a percentage, you would times by 100 to make it a percent, and your answer would be 48%. If you do that, you must write percent at the end of the line. Because it gives you extra to do, I'd advise against it, to be honest. Right, let's have a look at another question. So a student uses an electric motor to lift a mass. He investigated how the efficiency of the motor varied when the mass was lifted. The diagram below shows the apparatus used. Energy is transferred by the to the electric motor by the power supply. Why is the energy transferred to the motor greater than the gravitational potential energy gained by the mass? Now, notice this says tick 2 boxes. I am throwing away a mark if I don't tick 2. If I'm not sure which 2 to tick, try and narrow it down. So, energy is not conserved. Well, I know it can't be that one because energy is always conserved. Some might be wasted, but it is always conserved. I can also rule out the bottom one. Wasted energy is destroyed. Energy can never be destroyed. Because I've ruled out 2 that it definitely can't be, I've got to tick 2 boxes. I've got 3 left. I'm definitely going to get a mark now, even if I get one wrong. So let's have a look. Friction in the motor causes energy to transfer to the surroundings. That's true. The temperature of the motor increases. Yep. That's wasted heat. Yep. And we know electrical things heat up. But let's just check the last one. Thermal energy from the surroundings is transferred to the masses. We'll know the surroundings aren't heating up the masses, so it's not that one. So we know we've ticked the right 2. So we were required to tick the 2 essentially that showed why energy was wasted. which is why the energy going in isn't the useful energy coming out, because some is wasted. The efficiency of a motor is 15%. The student calculated that the useful output energy transfer was 1.2 joules. Calculate the total input energy transfer. So again, I write out my equation. So useful out divided by input. Now, first thing I do is I put my numbers into the correct place, but I've noticed they've given me the efficiency as a percentage. I want to put the decimal efficiency into here. So 15% as a decimal is 0.15. So I'm going to put my efficiency in as 0.15. That equals, and I've got the useful output energy is 1.20. So 1.20 divided by my input. Now I've got a mark here already. I've actually got 2 marks. I've got 1 mark for turning that into a decimal, 1 mark for writing out my calculation. Now I need to rearrange my equation to make input the subject. Now input can't be the subject when it's on the bottom of a divide. So what I'm going to do, I'm going to times both sides by input. So it's going to become input times by 0.15 equals 1.2. That still hasn't got input as my subject. Now input is times by 0.15. To get rid of times by 0.15, I'm going to divide both sides by 0.15. Also, to make it clear to the examiner, so I don't go off the bottom of the answer space, I'm going to go up here and I'm going to show the examiner I'm going up here with a nice big arrow, so they know how to follow my working out. So it's going to become input equals 1.20 divide by 0.15. That gets me another mark for correct rearranging. And then I use my calculator to find out that that comes out, when I type it into my calculator, as 8. So my answer is 8. Done. 4 marks. Now this one was a higher paper only question. So the figure below shows a roller coaster. The roller coaster car is raised a vertical distance of 35 meters to point A by a motor in 45 seconds. The mass of the roller coaster is 600 kilograms. The motor has a power rating of 8,000 watts. Calculate the percentage efficiency of the motor. So they're telling me my answer must be a percentage in the end. Can't leave it as a decimal. So again, I'm going to write the equation I know I'm going to need. I'm being asked to work out efficiency, so I write my efficiency equation. Efficiency equals useful out divided by input. Still just writing down my brief version of the equation. And I know I'm going to want percentage efficiency, so I'm going to times by 100. Now, we're told the motor power rating is 8,000 watts. Its power rating is the energy that needs to go into it. So that is my input. So I've got my input of 8,000. But it does not tell me the useful power output. I'm going to have to work that out. Now it tells me it goes a vertical distance of 35 meters. It tells me its mass. It tells me gravity, and it tells me a time. So all of these things I think I'm going to have to use to find the useful power output. Now the useful energy output is it's gaining gravitational energy. So what I'm going to do is I'm going to go, okay, so power is energy divided by time, and the energy is gravitational energy. So my equation for gravitational energy is mass times gravitational field strength times height divided by time. If I wasn't sure if these were the equations to use, the hints are that I need a power, because I put a power input, so I need a power output. And I was given distance, I was given time, I was given mass, I was given gravitational field strength. And these are all things that turn up in this equation. So I put my numbers in. So mass was 600, gravitational field strength 9.8, height 35 meters in 45 seconds. I will type all of that into my calculator. 600 times 9.8 times 35 divided by 45 is 4573.3 recurring. That is my useful power output. So now I can put it into this equation. So this is going to go in here. So my efficiency, useful power output, 4573.3 recurring, divided by my 8,000 input that the question gave me. And because I've still got this number in my calculator, I can just press divide by 8,000. And that gives me an answer of, oh, I've forgotten to times by 100. So times 100 gives me an answer of 57.16 recurring. And I will write that on the answer line. 57. Now notice that was 5 marks. That was a lot of marks. I've got 1 mark for working out the gravitational energy there. I've got another mark for turning that into a power. I've got another mark for putting that into my efficiency equation. I've got another mark for the answer, and I've got another mark for the rounded answer. So there's a lot of marks available. Now, your biggest hint is if you get a question with more than, I'd say, about 4 marks in a calculation, you're probably going to have to use more than one equation. Now let's have a look at one final question. The roller coaster rolls from point A to point B, a drop of 35 meters. Calculate the speed of the roller coaster at point B. Assume that the decrease in potential energy store is equal to the increase in kinetic energy store. Now, this sentence tells me what to do. Assume that the decrease in potential energy is equal to the increase in kinetic energy. So the decrease in potential energy, which I know is gravity, is equal to the kinetic energy. I know my equation for gravitational potential energy. I know my equation for kinetic energy. All I now have to do is put all my numbers into this equation, simplify and rearrange. So I could cancel the maths as if you're good at maths. If you're not great at maths, I'm just going to put it in. It was 600. So 600 times 9.8 times 35 equals a half times 600 v squared. I've got 1 mark for putting all the numbers in. I'm now going to simplify the left-hand side. So in my calculator, I'm going to do 600 times 9.8 times 35. So the left-hand side becomes 205,800. The right-hand side, I can simplify this bit. Half of 600 is 300, v squared. I now need to get v squared on its own. V squared is currently times by 300, so I'm going to divide by 300 to get rid of it. So divide 300. That equals v squared. I'll do that in my calculator, which gives me v squared is 686. And then to get out of v squared, I square root on my calculator. So v is the square root of 686, which equals 26.19. So my answer is 26.